Good morning, good afternoon, good evening, everyone. Thank you so much for joining the second lecture in our data preparation and exploration in our machine learning course, specifically titled Data Preparation and Exploration. My name is Dr. Abdelrahman Kotb, and I'll be your lecturer for today. As I mentioned in the chat, there's a Q&A tab. Please, if you have any questions, post them, and I'll do my best to answer them in a timely manner. So I'm going to start with the outline for today's lecture. I'm going to start by reviewing the first lecture. I'm then going to talk a little bit about the importance of data in machine learning. I'm going to talk about different data collection methods, data preprocessing, exploratory data analysis, some introduction to Python for data handling, and then I'm gonna talk a little bit about preview of lecture 3. And finally, I'm gonna summarize the lecture and open for questions. I would also be more than happy to receive questions as I'm lecturing. What I would do is as I get the questions, I will try and answer them. So I couldn't get the quiz for first lecture. So Dr. Garhi usually handles the quizzes. So if I wouldn't know where the quizzes are, but I'll sure ask him to make sure that he makes an announcement on that. Okay. Perfect. So what did we discuss in lecture 1? The main thing we discussed, and let me just make this smaller so that I can see the slide itself. We spoke about introduction to machine learning. We defined the different types of machine learning: supervised, unsupervised, reinforcement. We spoke a little bit about the history and evolution of machine learning. We discussed basic concepts and terminology, stuff like algorithm, model, training, testing, features, and labels. We discussed a little bit about the application of machine learning and real-world examples. We also discussed the machine learning workflow. And one thing I want to say is I chose this image specifically from the first lecture to show it today because in essence, this is a very simple yet very profound example of what machine learning is. You have, specifically with categorization, you have label data, cat, frog, dog, and you have new images that you're trying to learn what they are, and the model predicts what is the dog and what is the cat. Okay, so what is the importance of data? In essence, in machine learning, I think of data as the most important thing in machine learning. Because if you have good data that is accurate, complete, consistent, valid, and with integrity and uniqueness, you can develop the very strong machine learning models. However, if you take data that is not accurate, if you take data that is not complete, if you take data that is not consistent, if you did not validate the data, if the data is non-unique, then you can fall into the trap of what they refer to as garbage in, garbage out principle. So for example, let's look at the previous model here. If all the data that you gave the model to train are dogs, would the model be able to identify what is a cat or what is a frog? No, because this sample is biased. It's not representative of the population. Let's say you want to get to label a horse using this model. Would you be able to? No, because this model, as it is, only knows cat, frog, and dog. So this is just an example of what it means by a representative sample. The other example that I can think of is Let's say you own the dogs you give it are of one specific breed. Let's say French bulldogs. Then you give it another breed dogs. The model may have difficulty identifying what is a dog because it's only going to limit the features to that specific breed of dogs. And of course, the quality of the data directly affects the model performance. As I mentioned in the example I just highlighted, if you have a specific breed of dogs and you're only training the model on that specific breed, then that model is not going to perform well for other breeds of dogs. And again, this is why there is an importance of diverse and representative data sets. So how can we collect data? So that is a very broad question, and it really depends on where you are, what type of work you're trying to do, who's your audience, and so on and so forth. But in general, if you're trying to train or practice yourself how to do machine learning exercises, there are public databases, there are APIs, there is web scraping, and there are sensors. I want to start with the last one, which is sensors. This one I'd say is the most I would say the most challenging. But if you have the correct equipment, it's going to be one of the most valuable and one of the most, I would say, personalized data. So think of it as if you have a temperature sensor in your car and you're just collecting this data. So you're saying every day I'm driving X amount of hours and I want to make sure that the engine temperature does not exceed a certain value. Or you want to see that um, that hey, like what what is the relationship between car temperature and tires, for example, or car car temperature and performance. So that would be a very good one. For myself, whenever I think of sensors, I go back to the when I was doing my research and at university when I would put a sensor for temperature or put a sensor for a specific chemical interaction. That really helped me gather the data that I need until I made sure that it was representative, so that when I developed the model, it was data that is reliable because I collected it, but also data that was reputable with comparison to the rest of the community. Web scraping is, as the name implies, is going to websites and using what is referred to as a web crawler and getting data from there. So, for example, let's say you're looking at currency conversion. There are websites that provide tables for currency conversions. And you can look at currency conversion across history. And you can use this data to develop a predictive model for currency conversion or something like housing prices. The second one is APIs, or the third one is APIs, which stands for Application Programming Interface. So I see a question, what is an API? So an API in simple terms is usually a service provided by websites. So for example, think of X, Twitter, previously Twitter, Facebook, Google. They make it, they don't like, their data is their source of income. So they make it very difficult for you to web scrape. So what they usually do is they provide this service called API, or Application Programming Interface. This API is usually for a fee, and usually gives you access to the data because they make it in a way that web scraping is very difficult. So they provide you the service for a fee to get the data. And then databases. Databases usually in companies are very guarded information, but there are public databases that you can use again for training practices. For example, I was reading a paper on um, road conditions, and the author, eh, he looked up data from all roads in the U.S. and compared it to roads in Egypt, and he was able to develop a very good predictive model, saying for these conditions, the expectation of the lifespan of the roads is that much. And then what are the methods of data acquisition? There's manual collections, which is usually related to sensors, and then there's automated data pipelines, which can be web scraping and APIs. So when it comes to databases, it can be considered both manual or automated, depending on how you're integrating it within your data pipeline. So this is just a very good representation of what is a web scraping. So you look at an HTML website or a normal website, you do web scraping, look for specific things, and from that you create the data. And from this data, you're able to create features. And these features are what you can think of as a description of what is, for example, in the dog, frog, cat example, what is a dog? What is a cat? It has whiskers. What is a frog? It has a bulging mouth. Okay. So data pre-process. As someone, I've been working with data for a while, a little bit over a decade. Um, Data pre-processing is sometimes one of the most challenging things, especially when you have a lot of data, which in this day and age, the challenge is not usually having the data, it's usually knowing how to work with data. Um, Data pre-processing is a way to put data in a specific way, in a specific format, that it can be handled in and worked with in a simple way through algorithms. So a few guidelines in data preprocessing. There are three major, I would say, three main buckets of data preprocessing. Number one is handling missing data. Number two is data normalization and standardization. Number three is feature engineering and selection. And I would say the third one is the most difficult. And I'm gonna talk a little bit about why that's the case. So handling missing data, someone can tell me, why do we have missing data? And you can think of it in many, many reasons, but a very simple example is, let's say your traffic company, monitoring cars going through a red light, and you want to check like the different cars that are passing a red light. The question here is, what if the camera that's taking the photos that malfunctions during your data acquisition? You may lose the data, the images, but you may have like a QR code or another scanner that is taking the plate number. So this is a very simple example of why you may have some missing data. So what data scientists or machine learning engineers usually do is, there are different methods depending on how the data looks like. They can take a median, mean, or they can say, hey, we have enough data, let's drop whatever is missing. Data normalization and standardization. This one I would say, is becoming less and less of a challenge in this day and age, but it's still something that can impact certain models. So let's say you have data that spans from 0 to 1 million. Training a model on a large range of values can result in I would say in models not performing very well. Specific models. I would say the majority of the models. So what the most common methods of dealing with this large range is either normalization or standardization. Normalization is basically taking the 0 to 1 million and dividing it by the, in that case, the subtracting the minimum and then dividing by the maximum. So for example, in that case, let's say 0 to 1 million, the minimum is 0 divided by 1 million is going to be from 0 to 1. So this way, all the numbers from 0 to 1 million go to from 0 to 1. Standardization is similar, but in this case, data usually vary from -1 to 1. So that because this way you will have the data with a mean of 0 and a standard deviation of 1. And statistically speaking, the standardization is easier to work with, especially when developing models. The third and final way is feature engineering and selection. And what I mean by feature engineering and selection is picking what is relevant. So, for example, you're looking at your car's performance and you have weather, you have rain, you have wind, you have car type, you have driver, gender, you have a lot of things. You have the month of the year. Which ones are relevant and which ones are not relevant? This is what picking these things and choosing which ones are relevant and which ones are not is a challenge. I defining what to do with the data. For example, normalization, which is converting the numerical values from any range to 0 to 1, or standardization, which is transforming data to a mean of 0 and standard deviation of 1. That in itself is feature engineering because you're taking the data, you're changing it in a way, and then you're using that change data for the model development. For example, dates, date data. Algorithms usually don't work very well with just a date format. So, for example, July 6th, 2024, or May 5th, 2023. Usually, there are many, many ways of working with dates. The simplest way is to take the year as a feature, the month as a feature, and the day as a feature. So, feature engineering and selection most of the time requires some sort of domain expertise because you can pick a feature that is not relevant to your use case. For example, let me think of a good example here. So, for example, let's say you are trying to develop a predictive model to tell you when is the next solar eclipse going to happen. And you take the population as a feature. You say the larger the population that you have, the more likely I will have a solar eclipse. That's a feature. The population is a feature. However, in that specific example of solar eclipse, it is not relevant. And it really does not require an expert to say, well, solar eclipse is a is a cosmological phenomena, while population is something that is specific to Earth, and it has nothing to do or should not have an impact on the solar eclipse. Okay, so next we're going to talk a little bit about exploratory data analysis. So you remember the example I just mentioned on solar eclipse and how it is not impacted by population? Usually that can be inferred through exploratory data analysis. So what is EDA? What is exploratory data analysis? It is understanding the data distribution, identifying patterns, outliers, and anomalies. It is very difficult to find data that is clean without outliers and anomalies. That is unlikely. And if you ever encounter data that is clean, no outliers, no anomalies, someone has cleaned it. That is, I'd say 98, 99% of the chances. Understanding data distribution. So remember when I mentioned we can standardize, normalize. We made the decision of standardization or normalization based on this EDA. Is the data well distributed across a large range, or are these outliers that I need to remove? Another way to visualize data or understand the data is through visualization, through plotting the data on histograms, scatter plots, box plots. And this way you're able to visually look at the data and identify if you need um, you need to remove anything, you need to modify it, you need to standardize it, you need to normalize it. So I have a question: anomalies. Anomalies is, I would say, you can think of it as a defect, or I would say very similar to outliers in the definition of data. So so basically you can think of anomalies is something, or outlier is something that deviates or changes from what is expected. However, an anomaly is something that makes sense, but it's very rare and it doesn't happen often. And it's usually very different than what is expected. So in a sense, both of them are very different than what is expected, but anomalies are more of, that is, it's expected, like it happens and we know why it happens, but it's very, very rare. Where outliers is usually something that is an error in the data sometimes. But I would say from a data perspective, you can think of outliers and anomalies as very similar. Okay. Finally, is a descriptive statistics. So something like measuring mean, median, standard deviation, range. So these are all statistical definitions. So for example, let's say you're looking at, again, at the data from 0 to a million. What is the mean? What is the average? Is it 500,000? Is it 200? Is it 1,000? From that, you can get an idea of how the data is distributed. What is the median? Because usually the mean itself or the median itself is not descriptive enough. So getting both of them can be very helpful. What is the standard deviation? What is the range? For example, the range in this case is 0 to a million. And this is, I would say, a good pipeline of what we usually do with EDAs. So you look at descriptive analysis, adjustment of variable types. Let's say if you have like textual data, how you're going to manage the textual data, detection and treatment of missing data, identification of atypical data, and correlation of variables. How do the variables relate to each other? For example, you're looking at the car speed. and you're correlating it to acceleration. Are these dependent? Most likely they are. And if they are dependent, and I know we're going to talk about this later, it may impact the performance of the models. Okay, so introduction to Python for data handling. Um, how can we use Python for handling data? So the first thing is you need to have the data. Most data in Python is handled through CS Excel files. So either a CSV or XLSX file. That I would say these are the most two common files. CSV I would say is the most common that I've seen. After you ingest the data into Python, you can then filter, you can group, you can aggregate, you can create pivot plots, and you can create graphs. And this is all like loading and exploring data sets. So first thing that I usually do whenever I get data is I download it, I look at it, I see what can be done with this data, and then I make a decision on how to move forward. Are all the features relevant? Are the features correlated? Like, does one impact the other? And then we can do simple things like indexing and selecting data, choosing the data to move forward, applying functions, which is usually related to combining multiple features together, and calculating summary statistics. So looking at the mean, median, average, mean, median, standard deviation of the data. So what are we gonna discuss in the coming lecture? For lecture 3, we're gonna talk a little bit about supervised learning. We're gonna talk a little bit about model training and evaluation. We're gonna look at practical implementations of Python, and we're gonna understand uh, overfitting and underfitting. And again, I chose this picture. I think it's very simple, yet it takes the message forward on um, what is machine learning and what is the benefit. So for the last, I would say, half an hour, we spoke about these four main concepts, which is the importance of data quality, data collection methods and preprocessing techniques, exploratory data analysis, using Python for data handling. Specifically for importance of data quality, uh, we we need to make sure that we always think of the garbage in, garbage out principle. We need to make sure that the data we use is well processed and I would say, well collected. In data collection methods and pre-processing, we spoke about the different sources of data. We spoke about the different methods for handling missing values, normalization, standardization, feature. And I see a question here, when to use normalization and when to use standardization. I would say there's no general rule on when to use one versus the other. What I usually do is I try both of them and I see which one gives me a better prediction. And based on that, I would implement it in that specific situation. Methods of handling missing value. Will the running average will be good enough? Again, a lot of the times it is, but a lot of times it isn't, depending on the ratio of missing data versus what the data that you have. Because let's say the data that you have is from a biased sample, that mean, or at least let's say you're taking the ages of a certain group of people as one of the features. And you could not get the ages of babies because they did not talk. So you're only able to take ages from people above 5. Would taking the average of everyone be a good representation of the ages of these kids, of these babies that don't talk? No, it's not going to be. So in that case, the average is not going to be, it's going to make sense. However, in some cases, it does make sense. Exploratory data analysis. We discussed the importance of understanding data distribution. We introduced the data visualization techniques and descriptive statistics. Finally, we gave a brief, very brief, and I'm very aware of that, very brief idea of how to use Python for data handling. We spoke a little bit about pandas, the library, and how it's used to ingest data, to manipulate the data, and show basic data operations in Python. So this, and then, so what are the takeaways for this class, for this lecture? Number one is the importance of high data quality. Number two is the steps in data pre-processing. Number three is the key techniques in exploratory data analysis. And finally, some guidelines or some guidance on how Python is used for data handling. So this concludes the second lecture of this course. I'm open for questions. I think I answered all the questions as we were going through the lecture. So I'll give it a minute or two to see if there are any more questions. And if there are not, I will conclude the lecture. I will send the quiz to Dr. Al Garhi, and I will confirm with him to make sure that it is very clear where to access the quiz. So I see one thing on the chat. Is Jupyter Notebook most appropriate? I tend to use Jupyter Notebook a lot. So just for everyone's perspective, Jupyter Notebook is a tool. It's not, and it can host multiple languages, but it's a very common and very, I would say, easy tool to use for Python. So I would definitely say Jupyter is a very appropriate tool. Okay, if there are no more questions, okay, I think I see a question. Will we have practicals in this course too? I will do my best to include practical examples either in the next lecture or the one after. The challenge is just introducing Python in itself can take some time, and so I'll see the schedule and I'll see if I need to add another lecture for that. So how can we normalize data when we're dealing with missing data? So again, the rules of thumbs include taking the mean, taking the median. However, my advice is always try different examples and see how well they help you with your predictive model. And this way, you don't create a general rule of what to do when you have missing data. You're gonna have a toolkit that you can try multiple things when you have missing data. Will there be a final project? I don't think there's gonna be a final project. I'll do my best to discuss these examples, live examples of Python as we go over next lecture or the one after. I tried to install Panda library in Python, but still get error. Can we discuss this in the next lecture? Most of the times, Pandas is, maybe I need to remember that. It's been a very long time since I installed Panda. Ahmed, if you can send me a note, what are you, like, how you're installing Pandas? Are you using command prompt? Are you using Jupyter? I will need to get more information to help you. Okay, so with command prompt, there is the easiest way is to write pip install pandas. Make sure you don't have any typos. Make sure that you've installed Python on your computer before installing pandas. Also, that's another one. Installing Anaconda and using Jupyter This is what I was thinking gonna say is I think it installs pandas automatically because it's one of the, I would say, fundamental libraries there. Okay, so I think we're coming to the conclusion of our lecture. Thank you everyone for listening and for your great questions. I will see you all next week, and I'll send the quiz to Dr. Al Garhi within the next 10 minutes. Thank you everyone, and have a good rest of your day. Goodbye.